Check whether he's back.
Yeah, he's back.
Pratap.
Hmm.
Yeah, hey guys.
Bye. Let's get started. Pin top charger है ना. Okay, we saw that Google Vision is a mainly from Google Vision kind of an API. I mean, Google's API. Now we'll get into Tesseract model, wherein Tesseract model has custom models and also inbuilt pre-trained models also. Pre-trained models in the sense, if for per language wise, you will have a couple of models also. So in Anuvaad, we trained couple of custom models for Tamil, Hindi, Kannada, Bengali, Malayalam, Marathi, and Oriya, around some 8 to 9 languages models. Okay, every all the models can be found out in start.sh file, where when the service is being start, uh, this the models will load and store it in the specified directory for Tesseract. So if you want Tesseract in your system, there is a specific configuration. I mean, you need to install Tesseract and some popular kind of what you can say. I mean, packages which needs to be installed on Linux or any other machines for Tesseract. Then only you can leverage Tesseract models to some extent to do OCR. Okay. So the main difference between Tesseract and Google Vision is Google Vision is trained on a much larger data uh, than each and every Tesseract model has. So mainly, Tesseract might have been the old OG in the OCR field. Yes. So the first OCR, I mean, it's the top rated highest OCR for all the, like, irrespective of the languages. Doing an OCR was a pretty challenging task. So Tesseract came out of the syllabus. So it's old also, and it still stands strong. So, but when using comparing with Google Vision and Tesseract, Tesseract is an open source one. You can anyone can come and use the leverage the open source models and uh, scripts. But Google Vision has much more capabilities and computes that can give you accurate OCR digital text comparing with Tesseract. So say like Tesseract is a 95% accurate. So Google will give you 2% extra, 97 to 98%. So it's that accurate, and so Google Vision can give you multi-language model also. If the image has any multiple languages in it, just give the images, so it will detect all the languages also, and it will give you detection, I mean the OCR also in a perfect manner. So it's can say that it's a multi-model kind of an approach in the API Google Vision. So in Google Vision, you have multiple varieties also, and in rotating label detection and text recognition and etc. things. So which cost some more higher than whatever the basic approach what will be using. So if you want that one, you can go and read those docs and compare with all those things and do a benchmark. So Tesseract, it's inbuilt one, and custom, you can make a custom model out of it if you have the images. So Tesseract is basically uh, when you send an image, it will directly OCR on all the images. It will not see if it is a, this is a paragraph or this is something like that. Just see, go, and it will give you the bounding boxes. Sometimes the bounding boxes might be different and it won't be accurate also, but it will give you the bounding boxes, the line level bounding boxes and all. So when you're training Tesseract, I would suggest that. So giving a one sentence or a one line level image for a training purpose, it's a better approach for, rather than giving a whole document or a whole image itself. I think Pinto and Sharath can confirm when you guys were extracting the text for Ulka data sets for Ulka. So it was a pretty much straightforward and seeing text and the line level images on level. So those images you can take and train it on, and you can make a model out of it.
Okay.
I can guarantee you that that model will work perfectly. So whatever data you have in Ulkana, so OCR data,
Yeah.
so all are ingested via Anuvaad only. Till now, there is no use case that has not come for OCR dataset for Ulka. Okay, so all the datasets which are scraped or extracted are being ingested in Ulka also. You can use those datasets only for training if you are required and if you want to train. So saying that Tesseract requires a large number of data, a minimum per language, if you are specifying, you need to have some variations in the data. You need to have, you should not have same uh, specific sentence or data in multiple times. And you should pass some variations, tilted images also, like slight tilt to 2 degree, like I said, no, should pass those images also. When trained on, so it can give you a better model. Okay, training scripts and all, you can refer Tesseract repository. It's easy and straightforward. Okay, if you want, I can align with one more session on the training session also, and can assign. But as of now, I don't have time. But in coming weeks, I will definitely contact you guys for that one also. I'll show short. I'll give you the KT. If you go to the OCR repository and toolkit of OCR toolkit, there is already one.
It's about also talk it.
This one, OCR synthetic data generator for generating synthetic data, duplicate data for training. Tesseract OCR is the one which you want to train on. These are the training sets. But nonetheless, I will give you the training, I'll give you the OCR benchmarking, error profiling, all these things, each and one by one by one. But when you guys want to do now, just contact me. I will just support with you. Okay. Other than me showing you now, just contact me and I will give you the support. Okay. This goes with the training pipelines. So now let's get into the Tesseract OCR service which we have in Anuvaad. Okay. All the directory structure and the folder structure is same as what we have seen in Google Vision OCR, whatever we have seen. Same as document digitization. The only changes are in with respect to calling the model, getting the data, and respective things. We're going to roach module, checks for validation. Next, the response and service goes for process input. Now in the JSON file from block segmenter, it will come to Tesseract OCR. So it will check for page informations. Page information will be the page, with page information only you can get the images. Next comes the text extraction. Same functionality what we have seen in Google Vision. Same functions are using. But the functionality and the code is different. Okay, the model we will be calling is different. But the output structure or the anything whatever we're getting will be the same. Say like getting the regions from see page C words, page C lines. All these things I have specified in that one also. Those GV server, even the resolution, page identifiers, all these things. Next, in the get text and the next upcoming features will be changing. Okay, even in the set background images also. These are all post-process images, which are not using Google Vision. Which in Google Vision also, this is a post-process only, setting background images. Same code in multiple services, multiple use cases. So in get text, we are specifying languages. In the input parameter, if there is lines specified in line layout or craft, we'll get the lines, file, page path, regions from block segmented regions or layout regions. Okay, and if there is words in the, if you are calling craft or line, you can call font info in the block segmenter, file properties, and particular index which images we are using. Okay, see, make sure and keep in mind that in Anuvaad, this digital service, it's written in such a way that it is independent of its own functionality. Okay, it's not depending on any other functionalities. Like, can it, there might be some dependence on other services like block segment require layout detection JSON, and layout requires this one word detector. But you should make sure that you keep it intact with independentness, wherein if you're calling a layout service, it should only call layout service, irrespective that the input parameter shouldn't require any JSON file or anything. If you're passing just an image or just a PDF path, that is enough. Okay, then you can extract those and you can on the fly. Don't want to store anything there. On the fly, you can extract those images, call them, crop them, and send it over to the respective uh, functionalities of OCR on. Okay, so it's written is like that. Okay, so now let's get text. In get text, we'll go to get line path. What it requires? It requires page output, page words, save path. Where okay, this we are getting this get fonts. First, we'll check for length of words. So before that, the page word is having more than 0, then we set the font property for that particular word of data. So what we have got from the block segmenter process. Okay, page words. So you can get it via block segmenter. How many words are there or anything such like. Then after setting the font property, as I said, it's the same thing what I explained in the digitization Google Vision flow. Height and width via bounding boxes. I said no. Y1, Y2, Y1 minus Y2. Like that. Page words, get the polygonal region. After that, make an intersection. If there's any bold or superscript kind of thing, make use of it, and add those fonts region. Okay. Make sure where exactly this page word is getting from. Okay, if it is more than 0, this font property will work. Next, segment region. Segment region here, in case in block segment, if you are not specified or if you are not making any region unification, you can call directly here. Okay, in that sense, if you are calling any tesseract services block segmenter, it's one minor thing, but it's not required at all. Okay, you can omit that one. Just layout and tesseract you can align and you can pass it on. Region unification, the same code, it's been added here also. Okay, region unification, what it will do, it will filter out the regions. There is any fonts in that particular line which is added via in block segmenter or any layout or something, it will add that. Add fonts, font in the key for this particular block. We'll add that same what we saw in get polygonal way. We're just checking the height of the region. Using that height, we'll just apply that. That is it for that line. Okay, that's how we will add the font. Now we'll filter out the regions. How we'll filter out the regions? We'll get the region, all the regions. The region should not be null. Okay, region should not be null. We'll check the height for the regions, wherein the same function, the same logic which we use for getting the height of that particular line. I2 minus y1. Okay, so just so just like I'm saying, this is a y2 and this is like y1. I mean y2 y1 like that. So in 0th index y and last index of y, these two minus, you'll get one height. Okay. If the height is greater than 0, you will append that particular height and you will return this filtered region. Okay, you will just return the filtered region. Don't worry about this commented functionality. That won't cost anything and it won't do anything at all for your cost. Okay, so again, get text label region will require the sorted pages region, whatever region you have specified now. Just now you have specified those region, you'll get those region. So previously what was happening, we were sorting using lambda function using the bounding boxes, but since this function gave wrong bounding boxes and wrong functionalities, so we just commented out and just using the page region as whatever we are getting in this one. Okay, now next we got the text region. We have the table region also, table regions, images, header footer regions from layout also. We will get that, we are getting that from region. Okay, we'll just specify in the variable and we'll call this get text table region, wherein it will check for text para, header footer, table, image. Wherein we want to omit these image regions, we should not now pass image regions. We should not pass image regions. If there is image kind of or a graph kind of structure in the particular image, you should not pass that. There is no use for OCR. It will just give you gibberish data, right? So you should only check for text or para, header, footer, table, cell, those kind of regions. Now this, now after this region unification, uh, filter regions we got this text labels also. Now table region, we will remove the table region. So it's somewhat it is removing. I said no in block segmenter also. You have to see why exactly this is being removed in the first place for table regions. Okay, as it will verify. So here also you need to check the same logic, the region unifier, and you have to modify. Getting it? You have to modify this region unifier, same as block segmenter, whatever you're using. If you're using block segmenter there, don't use here. If you're using here, just comment it out there. Okay, just make in sync with the services. That's all. After these things done, filtered, what region? Please 1 second. Okay, sorry about that. Once we okay, let's continue. Okay, for this particular functionality, region unifier, just check it out with yourself and check out the logics uh, and see what exactly it's happening there. So basically, it's sorting out the region, and I mean, if there is any table region, it's messing it up and it's removing the regions, all the regions, and making the final region as empty. I mean, it should not have happened. Just check out with that. And after region unifier, we get the list of items to be processed on uh, Tesseract, wherein we pass the list of textual path, the regions data, the path of the image, language, width and height of the image. So in multi-process, so first we will read the image. We will get the mode height of the image. Mode height in the sense we have got the region, we have got the page region. We'll get in that region. We'll see for uh, line level data and page lines, and we'll get the page lines. So in that page lines, we'll check the height of that particular bounding boxes. Height in the sense, what is the height of the line level data, the rectangular box. Why same functionality? Here for checking the particular height, we need only one thing, the coordinate of y1 and y3, and y0, y3, check with that index. Don't bother about that. If I'm saying y1, it's be sure that you will be having four things: y1, y2, y3, y4. The last one, y01 and y3, first to last. Okay, so you'll get the frequent height. After after you get the mode height, so language detection will be happening. So Tesseract already has this language detection model, okay, wherein you are already specifying one script in PDF. If it can read PDF and it can get the text, okay, but it's not that accurate getting the image in OST, okay. So for that particular purpose, what we are doing, we are specifying what language it has been using. If the language is already there means we will not add anything. If it detects any new language, we will download it from the official open source Tesseract model. Say like I have 9 languages. Say somewhat is something like Assamese language is not there. Okay, Assamese language is not there, and I want to add it. So this particular piece of code, I mean, it will detect that particular language. Tesseract image to OST, it will detect the language, and it will say that okay, this is required, boss. So you need to download it. So this functionality will check the particular file for that, if the train data is there or not, and it will just replace it. I mean, it will just download it and place it into the Tesseract folder. Okay. So this is how the language detection will happen. So after that, it will check the length of page regions. So it should have the page region should be always greater than 0. Okay. We'll check the page regions, and it will check for first. It will check for table. If the page has if any table kind of classes or anything, it will do a table OCR first, wherein it will check for the regions, each and every cell regions, wherein lines or if there is any cell text or lines in that particular table region, it will go into that region and it will go into that word and make crop out of it. You already have that bounding boxes around you guys. Okay, you get the left, you get the top, you get the bottom. Okay, using the bounding boxes, you adjust that particular crop that for that particular cell only, not all the level. So each and every level like para, line and words will have the bounding boxes. For each and every cell level, you will have that crops. So you adjust that crops using adjust crops functionality, wherein you validate the region coordinate if the region belongs to the same one. Get the boxes. So firstly, make sure that you set right crop configs initially. How much you wanna crop till. Say like I have specified as -7 to 0. This is the crop config which I have specified. Using that, get the box coordinates first. Bounding box coordinates, whatever you have specified. So after that, finally do a collection of array of the whatever the box you have appended on for that particular block of chunk of data. Then crop that particular region. How will you crop? See the box perspective. There is already one perspective transform config is added, where if this is true, get crops per transform data, saying that width and height. W is the width, max of absolute of box of data. The first one, the first coordinate 0, x of 0 of 0, and x of 1 of 1 box of data. Then box 2 of 0 and box 3 of 0. Okay. This you will be getting it from the bounding box itself. Hmm? These are just indexes 0, 0 or 1, 0 or something specified. Okay, don't worry about the height. Height defaultly 140 is specified. So then you will calculate the box value of this height. At last, you will float it with respect to the box value, whatever you are getting. Using OpenCV, you get the perspective transform. Hmm? And again, you will result the same image from the perspective. You get the height and width of those images. You get the one crop of data. Cropped in the sense that bounding box crop. You get that image. Now you got the crop. So like if the crop is not none and if the crop shape is not greater than 3, always make sure that even in the crop also the shape should be not 2 but 3. 3 shapes should be there. Okay, height, width, and another one is what is it? Channel. Channel. Channels are like RGB or CYK colors. Think of that. 3 channels, not 2. If 2 means it's a gray. It's a gray format. It's not RGB. It's a gray format. 3 format. I mean, it should be have 3 formats. Then get the text particularly. Image crop is there. Language is there. Mode height you got. Left top and crop config and language detected. We got all these things. Go to the text function. Language filter first functionality. Check if the language mapping is proper. In the config language mapping, see we have specified couple of things here. Hmm? English, Kannada, Gujarati, Oriya, Hindi, Bengali, Marathi, Tamil, Telugu, Malayalam, uh, Marathi, Punjabi. So in the next version, Tesseract is not updated as Google. For your versions to update with Santili, Bodo, etc. things, you have to create models. There is no models. If there is a model, just onboard it and add these language configurations also. That's an immediate step what you have to do for working with the digitization process. Hmm? This language as language mapping will come from where your input file. When the workflow passes, it will pass a language code. That language code will be coming from here. Okay, so you will get this language mapping. Okay, if the double OCR is enabled, currently it is made false in defaultly, else language mapping will be started. If double OCR is made true, see if there are two models for this particular language code, Latin, or let's say like if double OCR is made to Kannada and Anuvaad Kannada, there are two models. Hmm? You have to call either one of them.
Currently, it takes default the first one. No?
Currently, no. Currently, it's take default the second one, the custom one, the custom one. See, for English, there is only one thing, Latin. There's no other separate custom-made models. Okay. See, that's what I'm saying. See here, if this double OCR is made to true, your original pre-trained tesseract, the official one will run. Else, your language mapping will call the second one. Yeah. Then comes the detected model. What uh, the tesseract image to OSD language it has detected. Say that if it is detected, if the detected particular thing is in the key, it will say that okay, this is the detected script, Latin kernel or something, and it will add it across. Okay. Else it will detect the whatever the map it is detected on the previous one. Hmm? Now the language detection is done. Okay, now it is done and it is perfect. Say like it is detected some other things which is not at all in this particular script, so that language will be added, map language data plus whatever the new one which is added, the additional language, so where it will download that particular language and it will store. Okay, now we got the language, we got the language filter, which language it is, We got the crop height, image crop height of 0, that particular image. Height check, median height into 5. Where are we getting from this median height? Median height, we are getting it from, uh, where is this? It's crops mode height. What we specified on the top at the beginning of the, this one. Okay. If there is a cell, just make it as to into 1.2 for only cell levels. If crop height is greater than the height check, which is specified in the median height mode height, then process this particular data, DFS, Phi tesseract, image to data functionality. This is calling tesseract model, image crop, config, PSM, keep always 6. Okay, keep always 6 defaultly, because it is good detection and good OCR is happening on 6. Don't keep for PSM 7, 7 or 8.
I changed for something to 7 or 8.
Hmm. But it's
for heading, that's for heading I guess, but since it takes only one sentence like line, so that is experimental based on
experimental you can do. You check exactly what is PSM. What's the full form of pixels? Some value is there, no? So it has some 1 to 13 values. So for table you have to specify this PSM. For text you have to specify this PSM. See, for detection and doing OCR, 6 is the best outcome. Use 6 or 7 at worst case. Don't use any other thing. If you just want to use tesseract, use plain old default. Default is PSM 3. Okay.
like for one scanned type. Last time it was not coming some errors.
Yeah.
For that I changed, it was working fine. So that some things.
You can experiment. There is no harm in experimenting, because block merger is using tesseract on, right? You can experiment and check. Even if now we are converting it to wholly custom made models, tesseract only, no? Test it with that. Okay, now we have specified if the crop height and height check is greater than the whatever we have specified, we will specify the PSM to 6. Language is specified. Output format will be a data frame, pandas data frame format. Okay, now we got all this. Now we got the OCR. Now next we will check the text text DF, wherein if it is if the given text or whatever we have got is correct or not, we will again fire multiple times to check the DF, whatever we have got. Let's say like we have just specified as temporary DF. Get text. Where did we go? So first we got this DFS. Okay, it says like this DFS, it's just a temporary DFS. Now we have to specify if the given text is correct or not. In the sense, again, language filter will be called. If the text DF, I mean, tesseract can give you multiple null values. If you have fire a tesseract image to data, it will give you null values in multiple places. For that, you have to specify that, okay, this is not null. You have to tell that this is not null, and you have to specify perfectly. That's where this PSM values comes around. Okay. So here we will do some pandas operation. For this particular temp data, we'll do that text should not be null. Okay. We'll reset the indexes in correct format. Say like if the uh, DF, temp DF is none and the length of the DF is 0, we'll again fire tesseract in that place. We have to cross check now. So again we will fire the tesseract on that same crop. Config set to PSM. This PSM, where are we getting from? We are getting from here. config.psm. Sorry, PSM we have statically specified as 6. Okay, when talking about crop height, if the crop height is greater than the height given by the mode value. So we'll again specify 6 language output data frame. So again it will check for not null, reset the indexes. So if it is not none and if the data frame is 1, in the sense if it is there, we'll check for text. If the text and temporary df keys and temporary text keys of 0, uh, if its instance is float and it will convert to string type. Okay, again this will call which one, image to string. To get the particular text, it's using 8 here. Hmm? You'll fire the language code here, you'll get the text. Again, there are some conditions for using double OCR threshold. Um, say like if the config of what you got on that particular text is less than whatever you have specified for this one, threshold 20, you will fire again that particular data using uh, other PSM values like 8, and again get the data and reset the indexes, and again say that if it is if it is correct, then you specify then you pass the image to string type and you get the text back. You already have that location of the data, the bounding boxes. You got that from that one. You just replace the text of that 0 into, I mean, you get the text properly, the digitized one. You get the text, then again, the same functionality. If the temp div is not none and the length of temporary div, whatever we have got from previous ones is 0, again we'll call 8 and get the data. Just we'll get it done. I think it's written multiple times here. We can remove this and this are pretty much the same thing. Here it's calling 6 and here it's calling 8. That's all. Okay, nonetheless. Now we got the, where was I? Process get test. Is this the one? Get text. Huh. No, I got the DFS for those words, and I will process those DFS with respect to left, top, language, and crop config. I'll align them in word by word by word. I'll get each and every word because I'm firing for all the words also. No, I'll get the bounding box. I'll see which word is that particular thing, and I'll specify the text. Because in Google Vision, if you fire, Google Vision will give you all these things easily, but in Desert it won't give you. So you want to get word by word by word. So from image to data, you'll get those. Sometimes you have to check multiple times to get those particular words. So that's why you have to play along with the PSM values and get those things and align them text similarly. Now the format is done. The DFS is done. Process DF. Sorry, it's done. It's done. Now the words are. It will return the words. Okay. The same thing will be followed for the down also. If crop config is greater than the height, whatever we have mode height, this function will go. Else it will be passed via this one. Okay. Config.psm value we have kept as 7 here. Okay. Default value 7. Else we'll be working with the 6. This one, it's done for which one? Lines in the tabular regions and cell regions. Cell regions we have done. I lost somewhere where it is. Main text extraction, get text, get bound, set fonts over, get segment regions over, multi-processing tesseract, table OCR done.
What does it mean, multiprocessing?
Which one?
Multiprocessing.
Multiprocessing in tesseract it's different. So you are using actually see in tesseract there is specifications for multi-processing tesseract, but in this code multi-processing tesseract is not used. Okay, you can view in there what exactly is multi-processing tesseract. I'll tell you what exactly it is. See, multi-processing tesseract is where, so say like if you want to specify, if you want to run 4 images at a time, tesseract can run one. You can run a script and you can run one at a time. But running for 4 images, tesseract will take some. It's like some. It will take 2 to 4 cores or something. It's based on the CPU cores, and it will run togetherly and get the outcome. To just fasten the process, they made something shortcut way. Okay, I don't think that will be used for our use case, but you can look into that and check it out. Here, multiprocessing tesseract in the sense you are seeing here in multiple ways. First, we will be firing tesseract. We'll get the image to data frame that will be treating as a temporary DF. Next, that temporary DF will take and we'll just move on to the next and check for not null values. And again, we'll try to hit the API for that particular prop if there is any null values present on the image. See, there is a box there, but the value is null. But the value should not be null there if the box is there. See, from image to data, you are getting the bounding box, but the value is null there. But why exactly is the value null? See, OCR should not happen if there is no text, right? But why exactly it is finding the bounding box in the first place? For that reason, you have to check multiple times here.
Will it
Uh,
get the crop and
yes,
run it again?
yeah, that's why it will get the crop. It will see with the other PSM values. As I said, self using that 8 or 6, defaultly it is 7 other PSM values. So any of them, if you won't get in any of those, use string PSML. If that also doesn't get, leave it. It's not,
then
yeah.
update the word.
Yeah, it will update the coordinate. If it's not there, it will not update. I mean, it will not update. It will. I will only take those that particular region. That's all. The check DF functionality is the same use case. Whatever what it's being used here. Okay. Now set for table. Same thing goes for the lines also. Lines is somewhat it's different than the table. Here we already have the, let's say like if this particular thing in the line in the config file, if is dynamic is true, what will be calling? Okay, where did you go? We have to make some chord adjustment. We already got the chords from where block segmenter or layout director or something. We'll make the chord adjustment according to the image and the line level region where we are having. How will we do that? We'll get the energy density and get the corrected regions first. How will you get the energy density? We'll fire the OpenCV, we'll read the image, convert it into grayscale, we'll fire the adaptive threshold and keep the threshold between 101 to 15. Okay, Gaussian adaptive threshold using Gaussian and binary threshold, and distance transform where mask size will be 5 here. So energy density 1 divided by distance transform, whatever we get, plus 1 square. Okay, that is what we get the energy density value of which one? That particular functionality, I mean that line, that particular image. So if we get that, we'll proceed with the same chord adjustment and move on. Then we'll correct the regions here. First we'll validate the region. If the bounding box vertices is less than 0 and will return false. Okay, check for negative chords. Check for orientation. If it is, if after energy getting energy density, if the box has been uh, made volta or something like that, you check for that using X values. Then you just return if it is true or false. The corrected regions, chord adjustment. You get the corrected regions here, regions and energy density. You get the corrected regions accordingly. So when you get that, you got this. It's called as template. If it is greater than 0, for that total line plus you'll add one more line onto that. Okay, I don't know why it is added, but you can check it on. Okay, okay, you asked for multi-process, right? So let's say like if currently it has been made to false. If configuration multi-process is there, we'll add lines to tesseract queue, multiple images, multiple lines. So which initially takes 4 to 6 crops at a time, and it will do. It will take around 2 to 4 cores of CPU, also some memory consumption. So if you have memory is too much, you can use multiprocess. I mean memory or CPU cores. Else, I wouldn't suggest to use this one. Okay, it will add these lines to queue. First, you'll get the for that particular regions coding. First, you'll adjust the crop, get the crop region, get the vertices of that particular bounding boxes, get left and top corrections, get the image crop shape. Okay, line metadata, image crop, mode height, coordinate. Mode height we already got from there for the whole images. Left to top, region index, the line index, which is from the class, what exactly it is, crop config, cx, cy, language detected, what languages is detected. All this put into a line metadata queue, multiprocessing. Put into a queue, 4 shot at a time. Else, don't do anything. Put into a queue. So here, add lines to a temp line. We have added tesseract queue, where it is. We are using multiprocess queuing system here, right? Tesseract. Okay, I missed somewhere. Text to get text. Madam, no OCR chord adjustment is done if the dynamic is made to true. You can experiment each and everything and making it true and see the outcome. I want to uh, show everything. Huh. So add lines to queue. Tesseract queue, language, image, mode head, region index, line class, and the uh, top left and top right. I mean, so in the sense, crop configs of whatever you are sending and language detected, and you will put this into a queue. Okay, tesseract queue. Say like if multiprocess is false and line is not none, and length of temp line is greater than 0, you'll you'll do what? You'll take the left. You'll have vertices. You'll take the left. You'll adjust the boxes according to crop configs. Adjust the crops. Okay. Now crop the region. If image crop is not none, and the shape is greater than 3, the image crop,
There are
3
some-
channels. There also get the tesseract text. Get the tesseract text. Again, the same thing. Language reduction. If cell is there, the same thing, same process. Image to data, those things. And then
horizontal merging,
check horizontal merging.
If in one
Yeah.
line there are like multiple boxes.
Yes.
Then just merge it as one box.
Yes. If there is any overlap or multiple boxes, just make it to one box. That's the logic of horizontal merge. You see, you will get the horizontal merging config. Line headers are mode height to 1.2 if the cell text is there. Horizontal merging is true here. So you'll merge these things. I mean, you'll just copy and you'll merge all these things. After that, done. Table OCR, crop regions, if image crop is done. Horizontal merging will be updated and you will update those lines. Say, let's, if config.multiprocess is set to true and file writer queue will be there. There is already a queue with file writer queue size. If queue size is less than the total lines, we'll put all those words into get keywords, collate those words. Okay. Say like we have this file writer queue size is greater than 0. We'll get the file writer and we'll append those words. Okay, again I lost it where it is. It's too hard to find. We'll collect those words. We'll return the page region. Okay. So this is one multi-process where the text extraction happen. Multi-process done. Get text done. We got the text. We got the bonds. We got these segmented regions. We got this list. Multi-processing tesseract. Tesseract is done. Okay. If you want to make any masking on the images, what we have got the bonding boxes.
Rest are same, no?
Rest are same, whatever you assume. But the masking logic you have to update here, maskcraft logic. So you have to update everything here and update accordingly in this thing. Okay. Masking, you can contact Pinto and he will get it for you guys. Okay. And there is one more thing. There is something called as stop correction. Sometimes desert model or any these models tend to uh, move text somewhat upwards a little bit higher than the bonding specified bonding boxes. If the top correction need is set to true, so you have to verify the table structure. So somewhat the cell level data it tend to move upwards than being inside the table, the texts. So for that you have to verify the table structure, wherein if the table structure is there, so you will delete those line level data, delete those regions and copy that region and do some operations, whatever it's specified. I think it's a simple one. You can view it on yourself. What exactly is that? But don't take too much time on this stop corrections and all. I think it's set to false as of now and it's not being used. If you want to experiment something around, just use it. There's nothing, no harm in that. Just verify this table structure. It will be, you'll get this list. After that, append it to output file and make sure that tesseract will be success. And this particular service, I mean, after this one, it will be sent on to tokenizer one. This is what the whole tesseract code, which is, I mean, the custom made tesseract, how exactly it will work. This is what it is. Okay. So you can't understand in one shot. You need a hell lot of a time to understand all these services. So I would urge you to take a look into this each one by one, each and every service, starting from file converter, word detector, layout, block segmenter, OCR, Google Vision, or OCR Tesseract. Take one by one, and start to do. Then you will connect the dots in each and every service, whatever it's happening, how exactly it is being interconnected to each other and each and every services. Okay. Now I'm ready to take any questions if you guys have. I have done the KT for Tesseract server.
Just one small query on this. So when
Uh,
we talk about Tesseract with OCR, the main idea is that let's say if a new language comes in the future, if uh, it follows the same script as of Devanagari, we are essentially using the same Tesseract model itself.
mm.
That is the idea that we'll be following, right?
Yes, yes.
Okay. So not much other questions from my end. I will once walk through this and try to implement it out. So I might have questions on top of it later on. So yeah, ahead in time, if possible, maybe we can connect once whenever time is available.
Sure, of course. Print of Sarath.
We'll work through this. We'll always dial you.
I'll be there, but yeah, but make sure that you guys are in line and just see what can be done. If not, ask people knows these things and they can help you. And reach out to me. But if I'm not available, just reach out to the guys. Okay. So just go through the KT.